Welcome, my dear learners. Today we are looking at limit at infinity. We are going to learn how to evaluate the limit at infinity of a function. Now let f be a function such that f at s is defined sufficiently for larger values of x. Then the limit of this function f at x as s approaches infinity is equal to L. Now before we start evaluating, let's look at the properties of limit of an infinity. So these are the very properties or rules that we are going to use to find the limit at infinity. Now the first 1 up to 4 is similar to what we have done in our previous lesson. That is, find the limit of a function at a point. Now the first 4 properties is the same as that. Now what we have added is the 4, the 5, and then the 6, which says that the limit of 1 over s exponent n as s approaches infinity is equal to 0. Now the condition is where n is a constant. So it means that when you have this function as x approaches infinity, you are going to get what? 0. An example is the limit of 1 over s squared as s approaches infinity will give you 0. Now the proof of this limit is in my previous video. You can go and then check it out. Now that we know the rules and then the properties, let's try to take examples and see how best we can apply them. So we have the first example. We are to find the limit of this function as s approaches infinity. Infinity, we are looking at what? Higher values such as 10, 100, 1000, 10,000, 1 million, 1 billion, and so on. So as s grows larger, so when you have 10 raised to the power 10, we are getting 100, 100 raised to the power 10, we are getting 1000, 1000 raised to the power 10, we are getting huge numbers. So as s goes higher, this function will approach what we call infinity. Now the second example, we have to find the limit of this function as s approaches infinity. We are going to get the limit as s approaches infinity of 2 times infinity plus 3. Now as I said, infinity, we are looking at all higher values. So 2 times any higher value such as 100,000, 200,000, 1 billion, we are still getting what? A higher value. A higher value plus 3 is still a higher value. Therefore, this function will yield what? An infinity. That's the limit. Now we have the next example, C. We have to find the limit of this function as s approaches infinity. We are going to apply the rules or properties of limits. So we are going to get the limit as s approaches infinity of 1 minus the limit as s approaches infinity. We can factorize 2 out and then we'll be left with 1 over s squared. Finally, we can get the limit as s approaches infinity of 1. Limit of a constant times a function is what? Is a constant times the limit of the function. So we are going to get 2 as s approaches infinity of 1 over s squared. Now we have the limit of a constant is what? The constant from property 1. So we are going to get 1. Then we have 2. Then the limit of 1 over s squared as s approaches infinity from this property 5, we are getting what? 0. So finally, we are going to get 1 minus 0 is still 1. That is the limit of what? Of the function. Let's take the next example. We have the next example. We have to find the limit of this function as s approaches infinity. So applying the limit, we are going to get infinity of 2 exponent negative x. The limit as s approaches infinity of 3. Now remember, we can write this in a fraction form because this is an exponential function. So you can get 1 over 2 exponent x plus the limit as s approaches infinity of 3. Now when we apply the the properties, from property 6, we can say that the limit of this will give us what? 0 from this very property. So we are going to get 0 here, and then the limit of a constant is what? Is a constant from property 1. So we are going to get what? 3. Now let's take the next example. So we have the next example here. We are to find the limit of this function as s approaches infinity. Now you can see that this is a rational function. Now to evaluate the limit at infinity of any rational function, we divide both the numerator and denominator by the highest exponent of x of the denominator. It's very necessary. To find the limit at infinity of any rational function, we divide both the numerator and denominator by the highest exponent of x that occurs in the denominator. So from here, the denominator is this very part. Now what is the highest exponent? Is this. So we are going to divide both the numerator and denominator by s squared. The limit as s approaches infinity of 3s squared all over s squared minus s squared all over s squared minus 2 all over s squared, then all over 5s squared all over s squared plus 4s squared all over s squared, plus 1 all over s squared. Now let's see if you can cancel. This s squared will cancel this s squared, this s squared will cancel this s squared, this and that will go. So we are going to left with the limit as s approaches infinity of 3 minus 1 minus 2 over s squared all over the limit as s approaches infinity of 5 plus 4 all over x plus 1 over s squared. Now when we take the limit of each of them, we are going to get the limit as s approaches infinity of 3 minus the limit as s approaches infinity of 1 minus the limit as s approaches infinity of 2 over s squared all over the limit as s approaches infinity of 5 Now let's apply the limit. Now the limit of a constant is still a constant, so we are getting 3 here, and the limit of a constant is still a constant, so minus 1, and the limit of this function as s approaches infinity, we are getting what? 0. Then the limit of a constant is still a constant, plus the limit of this function as s approaches infinity will give us what? 0, and then this will also round to 0. So we are going to get 3 minus 1 all over 5, and we are getting 2 out of 5. That is that. Let's take the next example. So we have to find the limit of this function as s approaches infinity. So this is a rational function, so we divide both the numerator and denominator by the highest exponent of what? X in the denominator. So we are going to get the limit as s approaches infinity of s squared all over s cubed plus 1 over s cubed all over 3s cubed all over s cubed minus 4x all over s cube plus 5 all over s cube. Now let's see if we can cancel. Let's go here. So we have the limit as s approaches infinity. We are going to get 1 over x plus 1 over x cubed all over 3, because this and that will go, minus 4 over x squared plus 5 all over s cubed. So from here, when you take the limit of this is going to give us 0, plus we are also getting 0 for this, all over limit of a constant is still a constant. We are getting 0 for this, and we're also getting 0 for that. At the end, we are getting 0 over 3. And the answer, 0 over 3, is equal to what? 0. That is that. So we have the last example here. We have to find the limit of this function as s approaches infinity. So we divide by the highest exponent of the denominator, which is what? X. So we are getting so after dividing, we see that we cannot divide this x by each of the numbers under the radical sign. So what we are going to do is we are just going to take root of x squared should give us x. So it means that in place of x squared, we can put what? Root of x squared, because root of x squared will give you what? X, so that we can divide it through. So we are going to get the limit as x approaches infinity of root of 2x squared plus 1 all over root of what? X squared all over. For the down, we are going to maintain it because we don't have any radical sign over there. So at the end, we are going to get the limit as s approaches infinity of big root 2x squared all over x squared plus 1 over what? X squared all over 3x over x minus 5 over what? X. Now we can cancel out this, and that will go here squared. So at the end, we are getting the limit as s approaches infinity of root of 2 plus 1 over x squared all over 3 over x. Sorry, this and that will go 3 minus 5 over what? X. So from here, applying the properties of the limit, we are going to get big root the limit as x approaches infinity of 2 plus the limit as s approaches infinity of 1 over x squared all over the limit as s approaches infinity of 3 minus the limit as s approaches infinity of 5 over x. Now the limit of a constant is still a constant. We are getting root of 2, and this will give us 0. Limit of a constant is still a constant, and this will give us 0. So at the end, we are getting root of 2 out of 3 as our final answer. So this is the limit. Thanks for watching.